In this video, we're gonna dial in the part and then make sure the orientation is correct, because if we see our bolt pattern there, on the bigger pattern, the first hole would be at the 3 o'clock position. So what I'm doing here is I'm going to set the part up and visually align one of my hex surfaces to be parallel with the back jaw, and I'm using the ruler there to project that further. And that V block that I have the part supported against has the notches in it, and I'm able to line up down, looking down on top of them. And in this instance, I don't even have to twist the part to get it tuned in to be parallel to the back jaw surface. Normally when I do this, I'm within 5 thousandths. And if I didn't use the ruler at all, it's hard to say how close I would get it to start with, but use a ruler. Maybe you'll get lucky and you won't have to twist the part to get it to be dialed in. So when you get a reading that's within a couple thousandths, call that good. You see there, I usually like to give my indicators a little shove forward and backwards to make sure that the travel is working correctly, especially if you ever have a perfect reading. Make sure the indicator is not stuck. Like in the other video that I have up on this channel about dialing in a part in a mill, I have a piece of 1/4 inch round stock aluminum, and I'm going to scale it in and find the approximate center before switching back to my test indicator, because the test indicator only has a 30-second of total travel, so you need to be pretty close to start with. One thing that so right here when I'm looking at my back and forth in the x-axis, I was having to tip the scale back away, and I thought maybe it was because the camera was in front of me, but what I find out as soon as I put the indicator in is I'm sweeping and it doesn't touch the front of the part. So I should have paid attention to what I was noticing with my ruler and moved the table or double checked my my y-axis orientation. But either way, I'm close enough that you'll see I'm able to dial this in pretty quick. Now I want to start, it's my preferred method, I should say, to start with this, I'm going to call it the x-axis. And I'm going to pick the camera up and make it dizzy. I wanted to try it like this instead of using a mirror like I did in the last video. So depending on where I stop, I'm trying to aim at the point. I zero the indicator. Now I'm rotating around. I'm away from the part, and then I never come back and I never touch the part again. So now I'm going to pull the table towards me until I pick up a couple thousandths worth of indicator travel. I'm on the 0. Now I'm going to swing back to the opposite side, and I'll see what my difference is in the reading. And it's really close. So now I'm going to go ahead and I shove the indicator in to get sort of in a more reliable section of the travel. And I re-zeroed it, so to speak, on the 15. And now I swing around to the other side, and I'm off a little bit. So now I'm going to go to the front where I'm not even touching, because it went counterclockwise till it came off the part. And then I just pull the table towards me until the needle wraps around to the 15, which is what I'm using as the 0. I think I'm looking at a really small screen. And yeah, I'm just going back and forth, and the outside surface of this part has been bead blasted, and it was really rusty. So when I'm looking at it now and I'm seeing, 2 lines worth of travel, that's at 1/1000th of difference. I'm not that worried about it. So right here I look at this and I say, you know what? I was minus 1/1000th. I'm at 0 on this side. That's good enough. It's a rough surface. I zero it out, and I'm pointing out that I'm in absolute mode. You can be in incremental, but it's best to set your zeros on absolute and use incremental how it's supposed to be. So I'm programming the bolt circle. First it says diameter. I enter the diameter. Now it says number of holes. Right there it says 2. I'm doing 8 holes, so I hit enter. And then the angle, so my 1.5" bolt circle, it starts at 0 degree, no angle. But any angle that the pattern started at, I would just enter in and push 0. So it's position 0 of 8, and then I'm going to hit enter again, and position 1 of 8, and it's telling me that I'm negative 750. So if I move the table to where, until the X read 0, then I'd be out of position to drill a hole. So all we do with this readout is we move the number to a different position and crank the handles until we see zeros, and then that's a position for a hole. And then you push the bolt circle button to get out of it. A lot of times students will come over and they'll say, hey, it's stuck in bolt circle mode. Well, no, just hit the button. Yeah, so what I'm going to do here is I'm using a spot drill. And a lot of times I just use center drills, but I am using a spot drill, and that's a 90-degree included angle on the spot drill. And what that tells me is for every thousandths I go down into the part, it will produce a circle that's 2 thousandths in diameter. So I brought the spindle down to a stop, the spindle stop, and then I'm going to raise the knee until I touch the top of the part, and then I lifted the spindle away from the stop. Now I'm going to zero the knee, and I think I go up 50 thousandths. I can't see on this little screen. And then I'm going to start the spindle and then drill back down to my spindle stop. So, you know, I'm always working off spindle stops. And from whatever size this is, I'm going to take a quick measurement here. And I'm thinking that, you know, if I'm at about 0.195 now, if I end up with a ring that's about 0.270, then I will have spot drilled my location and pre-chamfered my hole, because I'm drilling a 1/4 inch hole on this bolt circle. So I did the math, I raised the table, now I'm going to spot drill back down to that same in that same position, double check my size, and then if it's good, I'm going to run around this part and spot drill all the locations because my depth is set exactly how I want it. And that's what I do here. Oh, and actually I think, so when I check it here, I think I might have bumped the handle up another 5 thousandths. Because I think I'm getting like 0.266, yeah. I might have raised the table another 5 to make it about 10 thousandths bigger in diameter. So, position 2 on the readout, I just run the table till I have zeros in my X and Y axis. And then after this, I'm just going to start fast forwarding through the center drilling or spot drilling process. Now, I would use a spot drill and pre-chamfer my holes like this on smaller sizes, but if it was a 3/4 inch hole, then I wouldn't do it this way. I would spot drill and then drill a hole and then countersink with a countersink. So I got that in fast forward, of course. I'm not a CNC machine. And now I'm going to show 2 different methods for setting a drill bit to a depth stop. They're very similar but slightly different. So the first thing I do here is I bring the spindle down to the stop, lock it. I got a piece of paper, and I position the drill to the center of the part. So I'm wiggling the paper as I slowly bring the knee up until it drags against the tip. When I'm happy with that, I raise the spindle up, and then I'm going to go up the distance of the drill tip. That's the tip to the full diameter, and then another 1/4 inch, and that'll be the depth of the hole. So there's a simple formula to calculate the distance from the tip of a drill to the full diameter if it's a 118 degree included angled drill bit. And that simple formula is you take the number 0.3 and you times it by your drill's diameter. And if it's an included angle of 118 degrees, then you will have that number. And if it's highly critical, double check it. But with this part here, if you follow these steps like I'm showing you, you're going to be well within the tolerance zone. And I'm just going to drill all the hole locations, and I'll fast forward through this because it's kind of repetitive. But you will see that the holes are pre-countersunk because my spot drill, it gave me the countersink feature. Got my rapids turned up to 100. High-speed machining. And when you move from position to position, you know, I'll run both handles at once, and then sometimes I'll just run one and then the other. I stop the spindle to flick that chip away with my ruler. I could have probably drilled the last hole, but I wanted to show you, hey, don't use your fingers, use something else. So here, I set the spot drill to the diameter for this other inner bolt circle pattern, and it is clocked at a different starting angle, and I programmed the readout to accommodate that, and I didn't show it on film because I want you to have some, you know, challenges at the machine. And then I'm just going to go and spot drill all of these locations, and then I'm going to switch to my drill bit, and then I'm going to show you a slightly different method of finding your hole depth against the spindle stop. And it looks like this clip I did not get the clip speed turned up like on the last ones. They were running at 500%. And this one's running at normal speed, so. Now when I'm coming down with this little spot drill and I'm against the stop, I do let it dwell and have a couple rotations when I'm against the stop. And it changes the depth by a few thousandths, but having that slight dwell time gives you a more consistent diameter. Now that's in mild still. If there's some materials where I would not do that. I would either be cutting or getting away. Okay, so here's what I do. I'm against the spindle stop. My spindle's been lowered down. I'm raising the knee until the full diameter of the drill looks like it's level with the top of the part. Then I raise the spindle away from the stop, zero the knee, and then crank the table up 250 thousandths. So you'll see the table move here in a second. If you focus on like the back edge of the... Okay, I guess it already moved. Yeah, so then here I am in fast motion, drilling my holes. And you'll see this is great to pre-countersink these holes like this, because when I do it like this against the stop, every hole's the same. It's a professional looking part. and this will pretty much wrap up this project. Um, you'll use the bolt hole circle feature quite often in certain shop environments with the readouts. It's obviously a lot faster than having to do the hand layout like we did on our very first machining project.